review of the Edgenuity lesson, Inscribed angles. So to start off, I just wanted to remind you how a central angle works, and then we'll talk about inscribed angles. When you have a central angle, that's your angle and its vertex comes from the center of the circle. When you have that, your angle measure equals your arc measure. So if this was 35, this would be 35. If this was 50, this would be 50 degrees. Now, inscribed angles, now what we do is instead of having our vertex come from the center, it just has to be on the side of the circle. So here's our vertex here on the side of the circle, and then over here as well. Even though this looks different, there's an angle right here, and its vertex is right there on the side of the circle. For inscribed angles, the angle equals half of the arc. Of means multiply. So the angle is half the arc. I like to use this equation to help me set up my problems when I'm solving for angle measures so that I don't accidentally double or half the wrong thing. So looking at example 1, it's an inscribed angle because the vertex is on the side of the circle. And we're trying to find the measure of angle B. So again, the angle equals half of the arc. So we're trying to solve for the angle, and they gave us the arc. So it's going to be half of 50 degrees. Half of 50 is 25. So the measure of angle B is 25 degrees. The second one, we're trying to solve for the arc. Again, the angle is half of the arc because our vertex is right here on the side of the circle. So on this one, we know what the angle is. It's 110 degrees. And to undo this multiplying by a half, you can just go ahead and multiply by the reciprocal. So I'm just going to double both sides. It's half of 2 is 1. So we know that the arc is 220 degrees. So the arc is twice the size. So looking at example 2, it says, what's the value of x? So not a whole lot of information, but what I do see is that we have a diameter here. Okay, so AC goes through the center, which makes it a diameter, and then it makes this triangle ABC. So if you inscribe a triangle, that means put a triangle inside of a circle, and one of the legs is the diameter, then it has to be a right triangle. So this angle B here has to be 90 degrees. So 4x plus 6 equals 90. So then from there, you just solve the equation like normal. So we're going to go, first we're going to subtract 6 from both sides. So 4x equals 84. Then we're going to divide both sides by 4, and x is 21. Okay, last one, example 3. It says the measure of angle BAC, so that's this, oh, you can't really see it very well, I'll highlight it. This angle here is 4x plus 10. Then it says that the measure of angle BDC is 5x minus 2. And eventually we're going to find a measure of arc BC. So before we do that, we have to solve for x. Because this blue and purple inscribed angle, because the vertexes are on the side of the circle, because they intercept the same arc here, BC, they have to be the same. So not related to these values here. Let's just plug something in to make it make sense. So for example, let's just make it easy. If angle A was 10 degrees, BC would have to be 20 because the angle's half the arc, so this would be 20. If this is 20, that would mean angle D would have to be 10 because it makes also that same intercepted arc BC. So these have to be the same. So 5x minus 2 has to equal 4x plus 10. So I'm going to subtract 4x from both sides and add 2. Okay, so we know that x is 12. From there, again, this is the part we're trying to solve for out here. Arc, the measure of arc BC there. So first, let's figure out what this angle is here. So I'm just going to plug it in. Okay, so 4 times 12, that's 48. Plus 10 is 58. So I know angle A here is 58 degrees. The angle is half of the arc. So 58 is half of our arc BC. And again, if we just multiply both sides by 2, so we know our arc BC here is 116 degrees.